Hello, everybody. Welcome to this webinar series. Hope everyone is safe and well at home. Has been having a good year 2021 so far. At least it's been better than what 2020 had to offer. This webinar is part of a series of webinars, a learning initiative from Creator side that we have been organizing, that we started in 2020. The intention is to take up topics that are not traditionally thought of as possible in Creator and to explore, a kind of deep technical skill set and how we can help the community to understand the scope of Creator that is more than what is traditionally thought of as possible beyond its low code capabilities, specifically with the features that we tried to release last year in JavaScript, etc. So that is the goal of the initiative, and it is targeted at the developer community as a means and as an exercise of purely learning. This year, we've also tried to invite some experts. Igor here is literally our oldest certified developer. He was the first one to get certified and has been with us for 9 years now. And his expertise in software development has been phenomenal. And with respect to the use cases that he has handled in the past, he is one person that has been able to take Creator to another level with his expertise with other languages, etc. So we're very happy and welcome to Igor. We're very happy to have him with us today. Before we start the webinar, I would just like to inform you of a couple of things before I hand it over to Igor. All attendees will be on mute as usual. You can please ask your questions on the questions tab on your left pane. It will be handled at the end of the webinar so that the Igor, while he's presenting, he would not be able to handle some questions, but he might want to actually take up some questions during the webinar, as they would be as and when the topic becomes relevant. I already see that some of you have posted questions that are actually being covered in the webinar itself. A recording will be sent to all attendees. So in case you want to pop off for some time, it's okay, but we would prefer if you do stay throughout. Also, that this, as previously informed, this is a technical webinar and it does require deep knowledge of Deluge, a significant amount of knowledge of Deluge. And the topic as such, geospatial database, has been widely discussed in our community as well, and in many of our the use cases that we get to discuss with customers and our um, queries with support have all really talked about the topic of geospatial as geospatial database creator, how we can use it as that. And what we find is that there is a particular skill set of marrying the mathematics with creator, and we hope that this session would give you a good idea of how you can start off with it. So we request that you stay in for the whole session, because Igor has really prepared a wonderful presentation, and it would be really helpful for you because this topic has been highly debated and talked about as a use case. We would also like you to participate in the post-session survey. With that, I'd like to hand that over to Igor, who will take you through the session, what is the agenda, and everything. Thank you, guys. Over to you, Igor.
So let's get started with our webinar. Welcome on board on this webinar, where we learn about geocoding, geolocation, geospatial databases, and so on. So what exactly the geospatial data is? As you may guess, from the prefix, the geo is all about the points on Earth. And usually we have a deal with address field, and this is one of the main field related to the person, organization, etc. But the way how you can write the particular address, let's say street or st with dot, And other issue caused by human input leads to the situation that address field doesn't qualify as something unique and couldn't be considered as reliable identifier. So opposite to the address that might have different spelling, geodata is the way how we can represent the addresses in the computer comprehensive way. And the geospatial data usually is the way how the pair of coordinates or coordinate set is associated with given object. So what you will learn today and what you will be able to do after this webinar. You will know how to geocode the address using different techniques. You will know how to fetch the data using spatial criteria like range, for example, or square bounds. And you will know how to operate with geopoints like sorting. You will also know how to embed the map in the pages and in the form in Zoho Creator. For this, you will get acquainted with static map API, and you will also know the difference between static and dynamic maps. And also you will see how to generate the dynamic maps and utilize Zoho Creator as a spatial data set from external services. And all this task will be covered in the next hour. Now, that's the webinar content, but who am I? My name is Igor Watsenko. I'm freelance web developer, and I'm working with Zoho Creator mostly 10 years. And during this time, I have implemented a lot of projects and plenty number of integrations. I have profound knowledge of API and web technology along with Deluge scripting. And I'm very first developer, as it was mentioned, certified by Zoho and very first professional developer certified this year. And also I'm Zoho evangelist. I have started my blog 7 years ago and it named Zoholic. And this is the place where you can probably find some useful articles related to the Zoho. And aside of the Zoho Deluge, I'm also the JavaScript fan. I'm often use Node.js and Lambda functions along with AWS in my work for different integrations and ad hocs. And I developed some Zoho widgets for messaging like ClickSend, RingCentral. I developed the exec online integration. This is full integration with accounting system. And I have widget address type here on Marketplace. Also, I have some experience in developing mobile application using native script.js, but mostly I focused on the Zoho and Deluge. So now let's come back to our webinar. So let me make the helicopter view before we dive into. In the first module, we will learn all the core fundamentals we need to know about geocoordinates. What is the latitude and longitude? What is meridian and parallels? And what is the core of the spatial problem and plane approximation? And after that, we will have a helicopter view on real application and basic data structure. So after that, we will dwell into geocoding and compare the different approaches and address some problems related to the geocoding. After that, we will dive into the math. This would be such a boring session, but where we can get the way how we can calculate the distance, get bearing, and calculate boundaries. After that, we will have a look at how we can implement such functions and such calculations in Zoho Creator and address some limitation related to this. And that session will take in deep view on representational components, where we use all these formulas and generating the nice map and explain some methods to operating with geodata. And after that, finally, we will tackle a HTML widget, the new features of Zoho Creator, and show how we can use this technique inside the pages and other languages. And to crown all, we will have a Q&A section where you can ask your question and share your thoughts about this content. So, especially for this session, I prepared the GitHub projects which contain all the materials and code snippets we will use today, and also it contains our application as DS file. And I want to make a side notes here. Some of the functions in this application are user sensitive. I mean that they are use API key and tokens from different service, which I definitely remove from the hub. So using this function, you have to pass registration on correspondent services and generate your own tokens and API keys. So let's get started with knowledge refresh. So every location on Earth has a global address. Because the address is a number, people can communicate about location no matter what language they might speak. So latitude and longitude are lines, but instead of being straight lines on a flat surface, latitude and longitude are lines encircle the Earth either as horizontal circles or vertical half circles. So horizontal lines on Earth are lines of latitude. They are also known as parallels of latitude because they run parallel to equator. And generally, latitude lines are numerical way to measure how far north or south of equator place is located. And the equator is the starting point for this distance. That's why it's marked as 0 degrees latitude, and north and south poles are 90 degrees. Vertical mapping lines on Earth are lines of longitude, also known as meridians, which one end on the North Pole and other on the South Pole. So longitude lines are numerical way to measure how far location is east or west to the prime meridian. And prime meridian is the universal line that goes right over the British Royal Observatory in Greenwich in England. And this is also start point of time shifting. So Greenwich time, as you may know, also known as UTC time, and also known as Unix time in some software closed circles. So usually the global addresses is given as 2 numbers. However, you can also face in with canonical way of these numbers that contains minute and seconds after the integer portion of degree. And this is called DMS style. DMS, it's mean degree, minutes, and seconds. So I want you here to be aware how to convert DMS coordinates into the decimal, since all modern systems have a deal with decimal fraction. Actually, that's quite straightforward conception. So let me show you the application and how it looks inside. So I want to make, before the application, the helicopter view, what we will build here. So this application is not pretend to be something considered as a final solution. In this webinar, our goal is to show in one module different techniques and utilize the method exposed here. However, this is a great example of one of the use cases in some extent. So just take on account that I made some simplification and omit some business logic that not related to geodata, which is the subject of our webinar today. And anyway, imagine that we have a real estate agency and which have a database of apartment, and the our goal is to track scheduled meeting on site with the clients, but along with the scheduled event that we usually have an address and pointed map and set on time for sure. We want to visit at last to be aware of the nearest object which might be considered as an alternative right around our destination within some range. And this is very simple require but our application require all methods mentioned here, like geocoding, distance calculation, arrange the place in some order, and outputting data. So let's first have a look on apartment form that we have in our application. So our application contains actually 3 forms. So the one form is apartment form, and this form contains the object ID, title, address field for sure, and image. In the real life, it can contain other properties that require for business logic, but in this application, we are interested only in address field. So another form is a visit form. So visit form have a lookup field to our apartment. So the visit binded with some apartment and have a data and time field that indicates the particular time when this meeting will be. So also in this application, we have a copy of this visit form, and this is the stateless form that we will embed in the pages, and I will dive into this later. So for our application, I import the demo data. So this is about 1,000 of points in the North America, in United States. And these points I get from the open source. So this is sites that public the all apartments for rent. So I just create the filters that allow me to fetch 1,000 points. But what's crucial here that all these points have a real address, and all these points we can put on map. So let's take on our form. So here we have the title, here we have the address, we have apartment, we have city, state, we have a postal code, country, and we have a latitude and longitude. And this pin mark actually in Zoho Creator tell us that this address is geocoded and this address contains coordinates. But this not always be the case though. Usually data comes without latitude and longitude to the system. Therefore, we have to geocode this address. So let's take a deep view how we can get the coordinates for given addresses inside Zoho Creator. Thankfully, we have a method inside Zoho Creator geocoder. So let's inspect how it works. So in our application, I create in the function section that contains the different method for geocoding. And let's start with Zoho Geocoding. And this is pretty straightforward function. So we get, let's say, 100 apartments from our apartments database. So after that, we iterate these apartments. We store the address as a string. Let me comment for now this line. And after that, we utilize the Zoho geocoder function. So if, and after that, we just show, since we have all points already geocoded, we just show is the geocoding correct or not. And we also they count our success geocoded points. So let me start this function and let's take a look what's happening. As you can see, from 100 points, we have only 7 results. So 7%, this is definitely not we expected. So let's talk about geocoding. So the geocoding service is a black box which receives the address as a text and returns the pair of coordinates, latitude and longitude. Obviously, that the service which we will use for geocoding have a large address data set under the hood, and for each record have stored coordinates. So the engine outlining the address in the database and returns relevant results in some predefinite formats or number of results in some cases. The most of the platforms like this use 3 main elements involved into geocoding process. The first element is address normalizer, which takes the arbitrary string and normalize it. In other words, break apart and try to find obvious element. This allows us to narrow the search within the base. For example, filter the record within the state or within the city or within one zip code or even a street. So the second element of edging is worked based on principle that named Levenshtein distance. And this is kind of artifactual intelligence that allow to fix typo and some discrepancy in the addresses. So the core of this concept is that one changes in the string gives 1 point to the distance. And here we talk about evaluation distance that have nothing to do with geo distance for sure. On this picture, you can see the great practical example of Levenshtein distance, the water transformation from kitten to sitting, we can accomplish in 3 steps. And something similar used in the second section that recognize the address field. And the third element is some kind of interpolation of the street segment for omitted points. So for example, if Google have the geocoded block 1 and block 5 on the street, it can interpolate coordinates for the block 3 in between by eventually distribute the points between the given rooftops. And obviously, as a result of geocoding, we usually have a pair of coordinates, latitude and longitude, and some of API returns also additional info like success message, geocoding quality, and probably relevant information which reflected in their documentation for sure. Now, when we know how it works, let's take a look on our address in our application. So as you can see, our address contains the street. Let's open this record. It contains the street, the block, and they contains apartment. And this is something that we actually don't need for our geocoding. This is unused information. So let's come back to our function, and instead of using the full our address, generate a friendly name of address and omit the address line 2, which is the apartment. So use only the street, city, state, and zip. So we will run the same function, but with this address field that doesn't contain the address line 2. So let's execute and see. As you may remember, we have got the 7% of points geocoded last time. So as you may look, so now we have 10 times more. So, and this is the way how we can make even, how we can geocode the address. And I want to show you one more thing. So I want to show you another one function. So this is the, as you may know, recently the Zoho exposed their parse address function from artificial intelligence collection. And so before passing the address into our geocoding, we will parse this address through the Zoho parse address function. And in this case, we don't have to remove our apartment. We just call this function, and after that, generate the friendly address name from the instance that we have in the response. We use the house number, we use the road, city, state, postcode, and country. So let's call this function for the same number of points, and let's take a look what we will have. So the now result is pretty similar that we have in previous experiment. So actually, that means that instead of manually removing the address line 2, you can just parse this address through the Zoho built-in method. So I want now to show you one more thing. So we have here the Google Geocoding function, and I will run this function for the 30 results from our database. And this is exactly identical function to the previous one with one notice. The Google returns the quality of geocoding, and for our good result, we considered the rooftop results and geometric center. So geometric center, this is the center of block, and as you can see, all our points are geocoded. So we have mostly 100% of the points geocoded using the Google API. So let's take a look on the let's take a look on this table. So to chrome this section, I want to share this information. I think you can find the tens of API that provide the geocoder service. But what's the matter here is the source of data. I would say that we have 5 major data sources in the world. So this is 5 major competitors, and this is rough comparison of the services provided by this data holder. The most of API you will deal with have limitations which are the consequence of these services. And since we have time constraint, I will not dwell into the feature of each API and data sets. And this figures is my own estimation based on empirical experience. What's the matter here is that the most accurate service is the TomTom and Google. And I would say that Google is a not actually free service. The price model of Google is that they give you 200 monthly credits in front, which more than enough for everyday personal usage. But once you consume this money, they will charge you for each transaction. And this might be quite expenditure finally. Same time, setting the budgeting and notification on Google account is pretty tricky. Nevertheless, now we covered the main aspect of geocoding. You are able to choose right service for now, and now it's time to put our results on map. So in our application, I create for our apartments, I create the map. This is the new report introduced recently by Zoho, and it allows us to see 500 points same time on the screen. And you can also apply some styles. In my case, the apartment that have scheduled visit showed as red, and the all other showed as blue. So for this report, I create one custom action. So this custom action opens our visit form for the point that we choose. So if we click on this plate, we will redirect to the visit form with this particular apartment. So let's click on this, and you can see that we can schedule event for this particular apartment. And once we submit this, we are redirecting to the all visit report that shows us our visit. But as you may remember, our task was to show the nearest place to this visit. And this is something that couldn't be accomplished using the Zoho report. So for this, we need to utilize our own pages and external widgets. So let's talk about this. So the task of our application, as I said, is to show on map nearest apartments close to our visit, or better to say location within some particular range from given origin. But how to do this? How to know which points is closed to our origin, which closest, and how to get the distance to this point. This is pretty tricky task, and we will cover this very soon. Why the distance calculation considered as a complex task? Obviously, because this is not a distance through the line on flat surface. The S has spherical shape, and in addition, because of different, I would say, meaning of measurement of latitude and longitude from mass perspective. And here I want to make some explanation. The angle that represents latitude goes from the Earth center, so the distance between two latitudes, horizontal hula hoops around the Earth is proportional to the angle value, or rather difference in the angle value. By the way, the nautical mile is equal to 1 minute of meridian, which equal to 1 degree divided by 60. And the longitude measurement is crucially different than latitude. The distance is proportionally distributed along the horizontal line, but the circle length is quite different for different parallels. So for equator, the distance for one angle is pretty the same for the latitude and longitude. Nevertheless, moving to poles, the longitude is significantly shorter and became 0 on the poles. So to calculate distance between points on Earth, we are going to use spherical low cosine theorem and improving on this with Haversine formula. So, well, it's not a goal of this session to go in depth and prove this law here. You can easily find related information in the internet, but I want to say a couple words about accuracy of Haversine formula related to real distance. So this table contains the result of distance calculation in comparison with the real distance. And as you can see, it not depends on the distance between points, but it depends on latitude. And this is actually because our Earth is not a sphere. This is oblate ellipsoid, and therefore the precision goes down to the poles. Fortunately, we usually only care about the calculations in the populated area away from the poles. The Arctic Circle and Antarctic Circle is a latitude of 66 degrees, so the given result is quite the same for our purposes. I would say that error when we calculate the 1,000 mile is in the range of one block. So this is the generic implementation of this algorithm, which we will use as a reference. And here I want to draw your attention to a tan2 function. And that what's important here is these tan2 functions have nothing to do with arctangent. According to Wikipedia, this function returns the angle in plane in radians between the positive x-axis and the ray from the 0 points to xy point. And we will take a look on this function in the Zoho in a few minutes. One thing, the last but not least for our mass section is the value of Earth radius that we will use in calculation. As previously mentioned, our Earth is has elliptical shape, so the radius for the latitude and longitude are different. And experimentally, it was found that value that gives us the best precision is average of 2 horizontal and 1 vertical radius. And this is the reason why we use this particular value in the formulas, which might confusing someone who had a grade on geography. So now let's take a look on those functions in our application. So let's go under the hood, and I will show you our atan function. And I put here this function in one line. And the reason for this is the Zoho limitation. As you may know, we have the number of calculation allowed in one execution is limited for the most of account to the 5,000 operator. And Thankfully, Zoho considered one line of code as one operator. The good idea is to put all this function in one line. However, this is definitely not good from representational, from readability perspective. So this is a ton function, and this is the our sign distance, and this function gets the latitude and longitude of the source, latitude and longitude of the destination, and returns the distance. And important here that we returns here the distance in meter, which can be easy convert to the miles by dividing the result by 1609. So now when we have this in application, let me quickly summarize our section. So what now you know? So you know what does it mean geocoordinates, latitude and longitude. You know the geocoding process, and you know the address optimization, so you can address some you can clear your data and get the better results. We make comparison between OpenStreet and Google API. We covered the distance calculation with our sign formula, and we show the Zoho implementation of ATAN2 and our sign distance function, which you can find on my GitHub account. I think that we share this link in the comments. So let's go started with our next session that we mostly close the theory, and we can use now our knowledge on practice. So to coming back to our task, we want to fetch from the database locations within some particular range from given origin. And we will utilize here the function from our application, which was explained in last section. But what if our database have really a lot of points? Let's say thousands. Actually, this means that we have to calculate the distance for each point in our database, which may take a while. And what more substantially here may stack on Zoho limitation in the number of operators per one call. Let me remind, usually we can make only 5,000 operators in one call, and our distance calculation takes at last 8 lines. So to address this problem, let me explain you our next trick. So we now want to narrow our choice within some segment to reduce the number of iteration in the loop. And for that, we firstly define the boundaries for latitude and longitude range, in other words, upper, lower, and side bounds, which made rectangular segment and which sides away from our origin within given range. And then we will use our formula for distance for filtering. But how can we define the ranges we need? We know how to get the distance between points, but here we have the opposite task. We need the coordinates of boundaries within some distance on north, south, east, and west. And to get these boundaries, we have to solve more common task, which may be harmful for us, the get bearing or azimuth in other words. And for this case, we will use the reverse distance formula and its generic implementation. And this bearing function is also available in our application. Again, due to time limitation, we will not dwell into the math theory and the algorithm. We just cast here the final solution for this kind of task. So our function returns, let me show you. So our Boolean function returns the map, and this map contains the latitude and longitude. And as an input, we get a latitude and longitude of our center. We receive the angle value that goes from the north clockwise, and we receive the distance in meter. So this is the arguments, and as a result of this function, we will have the latitude and longitude of the point that we can use for in our calculation. So now to get the boundaries, we need to call our Boolean function 4 times. We need to call this for the north, for the east, for the south, and for the west. And in this case, we will have the address, we will have the coordinates of this point. And after that, we can apply inequity for fetching our points from the database. Okay, now we know the boundaries, but how we can use this in our expression? Hence, the address field have a latitude and longitude exposed as a string. So to address this problem, I want to show you then our next trick. So when we open our apartment form, you can use the admin section that is a hidden on load, but this section contains formula field. And here we have a latitude and longitude casted by decimal. So we just put the 2 decimal function and round this result to the 5 digits after the comma, because this is more than enough for our application. So now our apartment form have 2 decimal field, latitude and longitude, and the Deluge name of latitude and longitude is latitude 1 and longitude 1, since the latitude and longitude is reserved keywords. And now, when we have our apartments with decimal coordinate, we can use the range filtering our narrow choice. So once we get all points in the square, we can sift our result through the hover sign distance formula, since the number of points now is limited, and we can show the points on map within the circle from our origin. We can also get it sorted according to the range from the origin using the index, and I will show you this in the next few minutes. So in our application, we have all visit report. And you remember that when we choose our apartment on map, and submit the form, we redirect to this report. So, but now I want to redirect to the page that we created. And this page contains now points within the circle and the same points arranged by distance. And when we click on this related apartment, we can schedule another visit. So let's take the look under the hood in this page. So obviously this page received the two parameters. The one parameter is the record ID, which is our visit ID. And the second parameter is the distance. And by default, this distance is 20 miles. So inside the page, we have two parameters, as I told you. So this is record ID and the distance. And since that this parameter available for all internal widget on this page. So you can see that the second widget on our page is the stateless form that I told you on the very beginning. This is the copy of our visit, but stateless form. And here we have one interesting thing. I create the show apartment within drop down and add the automation. When we change this drop down, it reloads the same report with different value of distance. And this work in the, we can narrow our choice or we can extend the boundaries. So now this is regarding the stateless form, but most interesting here is this element. So this is the map. And what we have here under the hood. So we get our distance casted as meters, since all our functions work within the meters in our application. After that, we get the center of this map, and center of this map is our apartment that related to our visit record. And since we utilize in our application the Mapbox API to show a nice map, nice static map, they have a certain structure of the object that we pass to this map. So I create the list of the object that we put on map. So after that, I use the function that generate square bonds. And this is something that we already started here. So the square bonds is the function that utilize our bearing function. So we get the 4 points on north, on east, on south, and on west, and get from this point corresponding latitude and longitude, and return this as a lat min, lat max, long min, and long max. So this function, square bonds, returns us the latitude and longitude range for our square. And this is 4 points is definitely, this is the corner of our square. So after that, we generate the polygon with 4 points and assign the color for this polygon as blue. This function, this is just a helper function that create the overlay like this. So this is the text field that generate the polygon in given format expected by API. And after that, we put on the map the circle also as overlay. And circle, the function that works pretty similar to our boundaries. Let me show you. So the circle function receives the center, latitude and longitude. They receive the distance in meter, and they receives the vertices num. So this is the num. Actually, we draw on this map not a circle. We draw the right great polygon, and the number of corners of this polygon we also define in here. So after that, we split our 360 degree by number of corner. And after that, we iterate through the counter that we create and calculate the bearing for each of this azimuth with center in our point angle that we calculate as a step and distance. So actually on the returning of this function, we have a list of points with some, in our case, we cast the 60. So that means that we have a points on each 6 degree. So we add our circle to our map. And after that, this is the heart of our algorithm. So we fetch from apartment the points where the latitude is between lat min and lat max, and longitude also between our long min and lat max. And since the longitude and latitude cast by decimal, we can put inequity in the criteria expression. So we fetch 200 points. After that, we iterate these 4 points through the loop. We calculate the distance for each of these points. So we pass in the distance formula, the latitude and longitude of our center, and latitude and longitude of our points that we process it right now. And in case the range of to this point is less than distance, you remember the range returned in meters, and we cast the dist value also as meter. Here, we put this point on map, and we put this as a bluish marker. And finally, we point on this map, we add the red marker in the center with our center coordinate. So after that, we generate the URL according to the Mapbox documentation. And we have the simple HTML that put this image in the center of our panel. So again, here we have the bluish, this is our square bones. And after that, this is our radius that encircle our choice. And since we change the miles, we can show the different maps inside our page. And more interesting here is our second widget. So this widget shows us the points, the same points that we have on map, but these points are arranged by the distance. And I want to show you how this works inside widget. So here we have absolutely the same method. So we get the boundaries and we pick up all points within our square bones. So after that, instead of put these points on map, we create the distance index. And distance index is a collection or vocabulary, in other words. So, and for each point, if the distance to this point within our range, we put in this collection the key pair. And the key for our case would be the point ID, and for the range would be the distance to this point in miles. So finally, we will have something like this. So we will have the record and distances. And after that, we run the sort functions. We use the sort method that available for the collection, and we sort our records, we sort our instances by value. So after that, our distance index contains the record ID sorted by distance assembly. So After that, we extract the keys from the distance index from the R vocabulary and iterate this through the cycle and generate the HTML point for each of this item. So this is how it works. And I think that this is exactly explanation and about our static widget. So let's come back to our webinar. So to the summary of our session. We covered a lot. We covered the reverse Haversine formula. We know how to get the point on the circle, set an angle within some distance from our location. We know how to calculate the boundary. So we know how to expose lat long as a decimal using the formula field in the our form. We know how to accurate filtering our results to get the points exactly in some distance from our origin. We know how to sort point using location. And finally, we know how to display data using the static images. So now that you can notice is that at this time, talking about static images, which is a pictures under the hood, JPEG or PNG or GIF, the benefit of static images is that you can embed this in the page. And also you can embed this in the form as a node field, since all we have is a picture, and we can also use this in mobile application. Well, the drawback of static images is that your pages lack of dynamic that you can see on many sites, like nice animated maps with pop-up, balloons, and some kind on-click action. Fortunately, Zoho recently introduced the widgets inside Zoho Creator, and I want to show you how we can treat in with it in our application. So again, coming back to our visit form, now instead of opening view visit static form, I just click on this and this opens another page, and this page contains the JavaScript widget or HTML widget. And we can, this shows us the point. We can navigate on this map. And also we have here some dynamics, so we can click on map, show the pictures on this map, and also click schedule event right from our map widget. So let's take a look under the hood how it works internally. So actually our project, this is the boilerplate of the web widget that pretty good covered in the Zoho Creator documentation. And this is the folder there where we develop our widget, and it contains some styles for sure. And it contains also the simple HTML that contains one div as a map, and which call our application. And in application constructor, we have the pretty similar methods that we use in our static widget. So first of all, take a look. We have here the square bones function that receive the lat, long, and radius, exactly the same as we have in the Zoho Creator. The second function is our hover sign distance. So we have source latitude, longitude, and destination latitude and longitude. And we receive the distance in the meters. So nothing fancy here. So when we get the points using the API method that from Creator SDK, we provide the same criteria that we use in our static widget. Our latitude and longitude should be between the lat min, lat max, and long min and long max, since the result of this calculation exactly the same like we have in our static widget. And finally, we sift our points after removing some unnecessary information. We see through the distance through our distance function to make sure that distance to these points within our range. And finally, once we get all this, we get the points in our JavaScript. We put these points on map using the Google Maps JavaScript documentation. And we will not dwell into this widget and to JavaScript on this section due to time constraints. So my goal now is to show you that this is actually universal method that you can utilize from any languages that you might use in addition to Zoho. So this is just filtering, and after that, accurate filtering. Now it's time to talk about practical implementation and use case of this approach. You know, the software development is about limitation. We limit it in API calls, Deluge operator, records, etc. And actually, this is not a bad thing, I would say. The limitation is all about money. And our method also have the aim to save you some money. Alternatively, for example, you can use the distance matrix from Google API for such kind of task. But probably this will consume all your monthly quota, $200 in one day, which is definitely not good for production. So what is the limitation of suggested method? On the top level of application, assume that we use data for one particular business. And the total number of points is about thousands. What I mean here is when we perform the search within the distance, fetching the data within the boundaries, the number of our results is about couple hundreds, which we can treat in one function call, despite of Zoho limitation on a number of Deluge in one thread. Usually it's 5,000. For larger amount of results, you can consider just square bounds within distance filtering, since that costs nothing from calculation perspective, but will save you a lot of operator in your function. And square bounds gives you not a bad result, actually. For the system that holds millions of records, this method is unacceptable, definitely. What I mean here, as an example, let's say we need to fetch all businesses within 20 miles from the Manhattan center. The number of results could be hundreds, thousands, because we might have 1,000 points within 1 meter registered to the same addresses in the same buildings. And due to limitation, we can't process thousands calculation, and this is definitely bad user experience. So you have to find another solution outside Zoho for cases like this. Well, I think that I've exhausted of our webinar today. Now I believe you are able to build new amazing thing by yourself with Zoho Creator and Geodata and get your clients satisfied with your work.
Thank you so much, Igor, for uh, being part of this amazing webinar. And I think the response is very clear. A lot of people have found this very useful. If there is any other specific topic that you would like us to cover, please email us or you can put it in the chat as well. Also, please attend our exit survey so you can tell us what you liked and what you didn't like. If you also have um, some topics that you think would be beneficial to the community that you would want to communicate to the community, I think you can email us, and still then we will try to accommodate that as well into a webinar. So thank you so much. Again, contact us if you need anything else.